In this video I will demonstrate how to use this multimeter. I will show you how to measure DC voltage, DC current, resistance, continuity and capacitance. I've also got this example circuit here which consists of resistor and LED, and I've also got some unconnected individual components such as this capacitor and this diode, which will all be used to demonstrate the functions on the multimeter. So to turn the multimeter on, you press the operate button. Wait a couple of moments. The first function I'm going to show you is to measure voltage. So to measure voltage you press the VDC button. One thing to note is that to measure voltage you have to keep your red probe plugged in the red socket and the black probe connected to the black socket, which is here. Also, if you want to measure voltage, resistance, frequency or capacitance, your red probe stays here and your black probe stays here. It's only if you want to measure current that you move your probe here, but I will show that later on. So once you've pressed the VDC button, you are now ready to take a voltage reading. What you have to remember is that when you measure voltage, you have to measure it in parallel, so the probes must be in parallel. So like if I put the black probe here, this is my 0 volt rail, and in this case this is my positive voltage rail. You can see that the meter is showing approximately 5 volts, and that is how you measure voltage. Also, I can show you how to measure the voltage drop of a resistor and LED. So if you get your probes, and if I can just show you, so you connect one probe to one resistor leg and the other probe to the other resistor leg, and if you wait a couple of moments, you can see that the resistor is dropping 2.038 volts, and if I connect it to the diode, you can see, make sure you're making metal to metal contact, and the voltage being dropped here is 2.954 volts. If I was to swap the probes around, you would see that you would get a minus symbol. This simply indicates that you've got the probes the wrong way around, or the current's flowing in the wrong direction. So just flip your probes around and you'll see that you're getting the correct reading. And that is how you measure voltage. Next I'll show you how to measure resistance. For this part I don't require power, so I'll switch the power supply off. And to measure resistance you press this button with the ohm symbol. Again, to measure resistance you have to put the probes in parallel. So if I put the black probe here and the red probe here, you can see that the multimeter is displaying 326.6 ohms. You can see by the little ohm symbol that's next to the auto symbol that it's just ohms. If this was of high resistance, for example, let's say 300 kilo ohms for example, you could see that there's kilo ohm symbol, but in this case it's 326 ohms. So that's how you measure resistance. Next I'll show you how to measure capacitance, which you can do by pressing this button. And again, to measure capacitance you put the probes in parallel. So connect one probe here and the other probe here, and the meter is showing points, if I zoom in, .676 microfarads, and the value on the capacitor itself is 680 nanofarads. So if you multiply the value that was shown here, it would be 676 nanofarads, which is essentially the same value as this capacitor, depending on if this difference is acceptable for your circuit. It depends on your application. Anyway, next I'll show you how to use the continuity function. So to turn it on, you press this button, and if you keep your eye on the screen, you can see that there's currently an ohm symbol. If I press this button again, you can see it now displays millivolts. So this button has two functions. You can either use it to find continuity to see if there's a connection between 2 points in a circuit, or you can use it to find the forward voltage drop of a diode, which I'll now demonstrate. So if I zoom out, so let's say you don't know which side was the anode and which side was the cathode, then you just attach your probes like this to one end here, to the other end here, and you can see nothing has changed on the multimeter. But if I switch the probes round, you can see that the display's changed and it now displays 550.6 millivolts. So not only have I determined that this side is the anode and this side is the cathode, but I've also determined that the forward voltage drop of this diode is 550.6 millivolts. Now I'll demonstrate the other function of this button, which is to be able to find a break in a circuit or to find the continuity between 2 points in a circuit. So if I zoom out, so what I expect to see is when I put the probe here and I connect it to this red wire, I expect there to be beeping. Also, if you want to test that your probes are working before performing a continuity test, simply do this, and that beeping indicates that there is continuity from this probe to this probe, so you know that your probes are working. Anyway, so I'll now test that if there's continuity between this point and this point, and as that beeping sound indicates, there is continuity. Sometimes a wire may be broken internally and you may not know. This wire is perfectly fine, but if a wire was broken, then the beeping would not be constant. It would be on and off consistently, but this wire is fine. I can also test if there's a break in the circuit or if there's a short circuit. So I do not expect a beeping to occur when I put the probe here, and as you can hear, there's no beeping, so there's no short in the circuit. And this is especially useful if you have a complicated circuit or a PCB, as you can probe two separate pieces of the board and determine if there's a connection or if there's no connection. And that is how you use the continuity function. The final thing I want to show you is how to measure current. So in order to do that, what you need to do is disconnect the red probe, and then you have a choice of two sockets. Now if your circuit is going to draw more than 500 milliamps, then use this socket because it's got a maximum current rating of 10 amps, so the fuse won't blow until you reach 10 amps. Whereas if your circuit is going to draw less than 500 milliamps, then you can use this socket. Since I'm only driving a circuit with LED, I can use this socket as I'm drawing very low currents. And then don't forget to connect the black probe back into the COM socket, like that. And when you measure current, you have to make sure that the multimeter is in series with your circuit, which I'll now demonstrate. So what you essentially have to do is disconnect your power lead, get the red probe of your multimeter, plug it into the positive voltage rail, get your black probe, connect it into where your positive voltage lead was, like that. Then you press the button IDC to measure DC current. And then you simply switch the power supply on, give it a moment, and as you can see, the circuit is drawing 6.22 milliamps, and that is how you measure current. One additional thing, if you need to hold a value on this display, simply press this button, the hold button, and as you can see, that previous value is currently being stored in the primary display, but you've got a secondary display, so that if I turn the power off, that display is still active. And that is it for this multimeter.